All right, can you hear me? Thank you very much, and welcome to this presentation about containerization as a means of extending the lifetime of HTML development tools. Let me first start talking a little bit about myself so you understand where I come from on this matter. So I'm an electronic engineer. I joined CERN last year as a fellow, and I'm now working in HSC RPEL, where we work mainly on Chrome, which is a radiation monitoring system, where reliability is key and is a very important aspect to us. It has been designed using Vivado and Pita Linux 2018, so quite old software by nowadays term. And with the death of the death of CentOS 7 that is coming close, we're now looking to move to Alma Linux 9. One thing of a warning, I would touch upon a few security topics, but I'm by no means a security expert, so take everything I said on this matter with a grain of salt. And also don't hesitate to ask questions during or after the presentation, even long after. So you have here my email address. So let's talk about the main issue. So a lot of the proprietary tools we use for HL development are released with a few select officially supported distributions. And so that means that when that distribution reaches its end of life, you're a bit out of luck and need to find either to upgrade or to find some sort of a solution. On top of that, the distribution choice is limited by certain selection. So that's one more constraint you need to kind of deal with for the distribution selection. And one other thing that is slightly annoying is that Linux often does not target long-term support releases. What I mean by that is that, for example, if some software, let's take Vivado 2019, for example, it has been released for CentOS 7.6, but this is not the final release of the 7 series. It's actually 7.9. So all of the series up until the last one are declared end of life at the next minor release. So it means that CentOS 7.6 has been end of life at CentOS 7.7. So usually you can keep on using CentOS 7 because there should not be any big breaking changes between minor releases, but this is something that can happen. And so if that happens, you're kind of on your own. So there's a few solutions to that. You can try to upgrade the distribution nonetheless, even though it's not officially supported. So as I said, this is usually fine when you keep the same major version number, but it may break, especially when the major version is changed. And support may be lacking. You can go to Xilinx, they ask you on what distribution you are, and if that's not the correct answer, you may be a bit out of luck. So that's not necessarily the easiest solution. You can decide to stay on all distributions. So for us, that's mainly what we did. We are still, we are moving to Alma Linux 9, but we are still a little bit on CentOS 7. And so this comes with a few problems. CentOS 7 has been released first in 2015. So that means that some of the tools and software is not available. Python is a good example. You have a little chart of all of the end-of-life Python versions. And you can see that right now, Python 3.6 that has been first released in 2017 is end-of-life. CentOS 7 has been released in 2015. So there is no Python version that is not officially end-of-life available in the repositories. So that can be worked around, but it is a little bit of work. You may also have other issues. If you have brand new hardware, you may not have a lot of fun with very old kernels. Once the distribution is end of life, it's not very good security-wise. And finally, since 2015, I think the user experience in Linux has improved a lot, so you may enjoy the upgrade. Another solution is to always update your Vivado software. But if you want to be really serious about the releases and always be on an officially supported version of a minor release officially supported, this can be quite time consuming because you need to always be installing Vivado, finding what the missing dependencies are, and So this is costly, but also the design may need to be updated to use newer IPs. There are also changes to the build chain that may introduce bugs. One thing that comes to mind is undefined behavior in C that is maybe surprisingly easy to reach. And so long-term tests may be necessary, especially for reliability critical designs as for radiation monitoring systems. So this is not also the best solution. So you know the title of this talk. I will be talking a little bit about containers, but this also comes with a few issues because you may have a nice container. It's used by many people, but this is mainly for the server world. For the developer experience, it's not so easy to poke the right holes through the containers to be able to access your file system, to open the GUI, and also you need to create some sort of aliases to access Vivado, even though you're really trying to access Docker, Vivado through Docker. So for example, you don't necessarily want to always be calling Docker dash something and then Vivado, because you need to update all of your building scripts that you've written so far. So what would be really the best experience is to have Vivado or any other HCL tool inside of a container, but looking as if it was installed on the host system. And so this is where DistroBox comes in, which is the kind of the star of this presentation. And so this is a collection of shell scripts wrapping around Podman or Docker. So this is no more than shell scripts, but the idea is that it alleviates the developer by doing all of the dirty work you don't really want to be doing. This can, since it's built on top of container managers, it also means that you can use Adrian Bishuk great Docker images. And so you may even skip the installation step. I will not be talking too much about this because I want to stay as general as possible, but this is really something to keep in mind and a very promising approach. So to talk a little bit more about the main idea, the idea is somehow to install Vivado 2018 inside of a CentOS 7 container, but then to still be able to access it from the host system, where you can have all of the other software you want installed. And so the software is either available by entering the container or by using an exported binary or application. I will talk a little bit about that more later. And so the big advantage of using DistroBox rather than barebone Podman or Docker is that the integration is transparent. You will still be keeping your users, so there's no permission conflict. The GUI will work just fine. Audio, SSH agents, all of this will work out of the box. This is where I touch a little bit about security. This is actually a slide I've taken from the main developer of DistroBox. So this is not a security enhancing tool, so you shouldn't install software you don't trust on this because there's been holes inside of the container. One of the good side effects is that if you are using rootless Podman, you may be root inside of the container, but not root in the whole system. So you shouldn't be able to nuke your system, though you can still do bad things. And concerning the end of life distribution, the attack surface will be reduced if they are inside of the container, but the distribution is still running underneath and there are holes inside of your containers. So this is somewhere where I would love to have some input from more knowledgeable people about security. Concerning compatibility, really anything that runs inside of containers is compatible. So it means that you can install distribution as old as Debian 7 and CentOS 7 up till distributions that are available now. And DistroBox itself will work on most modern distributions, including CentOS 7, Alma Linux, and Red Hat 8 and 9. So you could install Alma Linux 9 software on CentOS 7 and also the other way around. So this is quite a flexible approach. And concerning performance, containers are not virtual machines. This means that there's little to no overhead costs, so only 1 or 2 percentage points. And you can even be faster running software inside of the container than on the host system. So there will be no issues on the performance end. Let's talk now a little bit about the workflow. So you will want to download the installer that you need. So exactly when you want to install in the host system, you will create a new DistroBox container through the DistroBox create command. And then after the image option, you can give it any available Docker image, be it local or inside of a repository. You will then need to enter the DistroBox. And this really is looking like if you are SSHing to a machine. So you will see the host name changing, and then there you will be actually inside of your container. So in that case, you will really be inside of a CentOS 7 machine that is located on your machine. Then you will install the software and its dependencies exactly as you would on a host system. So really there's no difference there. You will open the GUI will open, and you will continue with the installation exactly as on the host system. Finally, you will need to export the application, and by that, DistroBox will create some sort of a shortcut from the host system that will connect to the inside of the container. And so this is done through the DistroBox export option. You can export GUI applications with the --app indicator, or command line binaries with the --bin option. You can then exit the container, you're on the host, and then you can start using the exported binaries as if they were installed on your host system. Before I go with a small demonstration, I just want to be talking about the pitfalls, because there's a few that you need to be aware of if you want to try this yourself. First of all, Vivado or proprietary tools don't always play nice. So for example, the launcher file, Vivado puts it inside of the desktop, and this is not a standard directory to be putting these type of files in. So you will need to correct that by moving the desktop file to the correct location so that DistroBox can actually discover it. And also environment variables need to be sourced at login, meaning that you will need to source Vivado settings inside of the /etc profile file or inside of the profile.d folder. There's also a few known bugs inside of DistroBox, which are that if there is a space inside of the desktop file you're trying to export, there will be issues. And some arguments of exported binaries may not be passed correctly if you start to be doing funny things. So the fixes are known and are being worked on. But in the meantime, if you want to use myfork with all of the necessary patches, they are available at that location, and you may clone and use that very easily. So this is time for the demo. And so there I will guide you through the installation. I will be using Alma Linux 9 and then installing Vivado 2018 in a CentOS 7 container and exporting that so that I can use it on the host system. So let's start. First of all, I will need to install DistroBox. So I will do git clone and my own repository. You will see that it clones all of the thing. You go inside of the directory. You type /install. So you don't need any sudo permissions in order to do this, and it will install inside of your home directory. There is no compilation because these are all shell scripts, so this is why it's so fast. You will also need, just a warning, you will also need to install Docker or Podman, whatever you prefer. Then I can go up a level, and I will be creating this CentOS 7 container. So there I'm using the one which is available in Strand's repository, and I name it CC7. So that is done. I will now need to enter the container to enter the CentOS 7 environment. The first time setup can take a bit of time, so I've sped up a little bit the video, but this is only done once. So once that is done, you will be able to enter and exit the container instantaneously. Okay, getting there. All right, and now you're inside of a terminal, which is really CentOS 7. You can look at the configurations and everything, but the important thing is that you will still have access to all of your desktop files. All of your home directory is the same. Your user is the same, so you have the exact same rights. I will then go on and install the dependencies needed for Vivado. So this is also something you need to do when you're installing on your host system. Then I create the folder where I want to install Vivado and give it the correct rights. So then again, it's nothing too surprising. And then the installation process can begin. So it will take a bit of time. So I will skip again because Vivado 2018 needs to use the all-in-one installer. So it will take time to actually extract all of the files and start running that. So everything is sped up. But then again, there should be no surprises because it's exactly as if it was installed in the host system. You can see that window opened. So no problem with the GUI. You know that this is inside of the container because on top of the window, you can see on cc7 dot something. And so you see the name of the container there. So it's really as if you are SSHing and using X forwarding. A few things went quite fast there. So what I've done here is that I've basically written the source command inside of the correct directory so that the environment variables are sourced correctly. I have copied the desktop, I should use the mouse pointer probably. I've copied the desktop file to the correct location, as I was saying before. And then I've exported the Vivado app as well as the Vivado binary. So there you can exit the distro box and you're basically done with the installation process. It's you can now enjoy using Vivado. So for the app, the integration is really nice because you can just open the app launcher as you would for an installed app, type in Vivado, and you will see that there is an icon appearing there. And you just need to press enter, and this will actually launch Vivado. So Vivado is quite slow, so you will need to wait a bit in order to see it open. I will actually skip a few seconds. But you see Vivado there and the window open, and you can create your own little project and everything will be working as usual. So I will then skip again, but you can see that I can create a project and access to the main thing, no problem whatsoever. Let's now check out the Vivado binary. So this, then again, you can just call Vivado, and you have you can run, well, whatever. This there I will just run a very short script, just printing some things to the terminal, and you can see it's starting up, and then printing everything correctly to the output. And so there you have it. And there you have it. And before I end this presentation, I want to have a few highlights. So I want really to thank Adrian Bishuk and his team for the work on the containers and his help with DistroBox. So that was very appreciated. And also I want to thank Luca Di Maio, who is the original author of DistroBox. And some inspiration has been taken from his presentation at the Open Source Summit Europe for this talk. Thank you very much. Is there any questions?
Thank you, Clyde. There are some questions in the room.
Okay. Hi, thank you. That was quite new for me, at least for me, quite interesting. I have a question, I think, to the workflow on slide 13, if I remember. Yes. You are entering the distro box. Basically, you enter the container and you start installation inside the container.
Yeah.
Right. However, normally in containers, what you install when the container is stopped and started is gone, because when you start container, you start basically, you have only the files that were in the Docker file when you build the container.
Yeah.
I wonder how is it here with the persistency?
So the container is actually started in the background, and you can shut. The thing to note is that the goal is a little bit different between the server world and in the server. Usually you want something that is very reproducible, and that's why when you exit your container, you start your container new again, you will find the exact same environment. There actually you will not kill the container. So you have the image, you create a container out of the image, and as long as you don't delete the container, you will still be able to stop, start it again, access it again, no problem on that end. So this is really persistent as long as you don't play with commands and delete forcefully the container.
Okay.
Does this mean that the image is not created, but just a container on top of the image? So if I do button PS, I would see there is a container always running.
Yeah. You can stop the container, you can start it again, as long as you mention the container and not the image, it will be fine. And DistroBox takes care of that for you. It will stop and restart the container if it's needed.
But
you can reboot the machine. The containers are the overlays for the containers are kept. It's just that DistroBox will mention the container and not the image. And this is also where so there's no like Docker file where you build the distribution out of that, because you don't really care about reproducibility. You care about having the software installed on your machine, and there will be no redeployment. And this is also something where Adrian's image could be interesting, because then you would be starting with the software already installed in your image. So there's no difference for the persistency, but that allows to skip the installation step and start already from something working. Have I answered your question?
Yes, I was wondering, because usually when we install the Vivado, since it is getting larger and larger beyond any measures, when we have to install another PC, basically copy the installation, skipping the installation files.
Yeah.
In the Andreas container, basically you copy the image. Here in the case, I think it would be more useful, instead of installing it each time on a new container, probably take the already pre-installed container and maybe execute 0.5, which is the exporting whatever it is container towards the host OS.
Yes,
yeah.
yes, indeed. This is the best approach. I've got experience only with the 2018 version of the image, but from what I recall, there's no desktop files included inside of the Docker image, because, well, for servers, it doesn't make sense. And so this will need to be added in if you want to be able to export that directly. But this would be the best solution.
You also had a question we had at the start.
No, Adrian wanted to react directly on this point. Sorry, I'll come back to you.
Yeah, so I wanted just to comment here, so that if you combine if you combine Clyde's approach with the distro box with the images that I've prepared, you pull the image with given Vivado version already installed there, and you just run a few commands to properly export it. And I have a merge request pending to actually include support for this DistroBox export command, but give me a few days once I finish this.
And as I mentioned in the pitfalls, there's stuff that we need to change slightly on DistroBox ends to make things really painless. So this is still work in progress, though very interesting.
So I just want to clarify some of the things that I didn't fully understand. So this DistroBox create command is generating a Docker image, but as a DistroBox image or something?
Yeah. I'm saying it's a DistroBox because conceptually it's easier to understand, but really behind the scenes, it will either use Docker or Podman, create a container, start the container, pull the image, create a container on top of that. And then the magic happens really when you do DistroBox enter. And when you do that, actually, it will kind of call Docker or Podman with a lot of different options, poking the correct holes inside of the container for you to access easily.
Okay, so you can use, for example, when you enter the CentOS 7, you can use Alma 9 applications inside the CentOS 7 and Alma 9.
This does not exactly work both ways.
Oh, okay.
But if you are using CentOS 7 on the host machine, you could install an Alma Linux 9
Docker
DistroBox from that and call newer software from there. Yeah.
Okay, that was I was wondering because then you can only call CentOS 7 applications from the Alma 9 or the original OS.
Yeah.
Okay, thanks.
Well, there may be some way, but not that I've explored. But there's still all of the main, like if you have an executable which is located in your home directory, you will be able to call it from CentOS 7 since the directories are shared. It's just not things that are installed are, I don't know, for example, is /user/bin. This is shadowed by CentOS 7 container. So you're not able to access that underneath.
Okay, that I wasn't aware of this, and it's great to know.
Thanks. There are also questions on Zoom. Wojciech?
Hello, everyone. Do you hear me?
Yes, we do.
Okay, so thanks for excellent presentation, which highlights a very, very deep problem that we all have. Here I'm representing mechatronics section of EP department, and I am the guy who is behind all the installations. And yes, indeed, this is a problem, the obsolescence of the operating systems. And since we are still have to support some designs, or at least to capable of opening certain designs from, let's say, 97 or something, you can imagine with all convolutions that we have with the applications. Here you were mentioning just one application, but when it comes to the EDA software, these are in our hands. We have hundreds of different revisions of software. So I was wondering, and my question is, there are other types of containers, and then there's one popular which is now, let's say, trending in the EDA vendors. I'm talking about ASICS ones. So the most, let's say, trending one is the Obtainer, which was called, I think, Singularity before. So my question is, when you were saying all these, graphical things, etc., it's coming out of the box with that one. Have you considered to use this one? I mean, the Obtainer.
I'm actually not aware of this, so this is something I will need to look into.
Okay. So this is something which is relatively, well, I don't say new. The only EDA vendor that out of three major ones, we are using Cadence, we are using Siemens, formerly Mentor, and we are using Synopsys. And it's Synopsys that is giving a sign of containerization. It means that it already supplies containers for some of their tools. So it looks like, at least for our side, concerning the ASIC world, we'll be heading into trying to use the Obtainer, which is, as I told you, the Singularity, was called Singularity before. But anyway, I would like to thank you very much for this presentation, because highlighting this problem is very, very, very important. Thank you very much.
Thank you very much.
Okay, thanks a lot, Wojciech. Luigi?
Yes, thank you. Super interesting. I will try that. I had a question about probably one of the most painful things that can happen is when the EDA tool requires a 32-bit and obsolete operating system. Have you tried running a 32-bit container and see if things match up and they work properly?
This is not something I've tried, but I know that at least with Podman, it has integration with QEMU. And so, for example, it's possible to run RM distributions on x86 hosts. So while I have not tried it, this is definitely possible.
But you need an emulator.
Yeah, there's an emulator layer, and then the performance will probably be worse. Though with 32-bit compatibility, I wonder exactly how that will play out. But various things to try out there for sure.
We had the same problem about the cadence application, and which in fact requires, let's say, Red Hat 5. We were deploying CentOS 6 image, 32-bit, and that, sorry, we were installing a 64-bit image, and on that we loaded all of the RPMs, which were 32-bit RPMs that we were needing, and somehow the application started. So it's a good sign, and that was done with Obtainer.
Okay, thank you. Are there any other questions? No. Well, thank you very much.